The next tool in the real-time tools section is to look at Spark streaming. It's a lightning speed cluster computing tool. It's built on top of Hadoop's MapReduce. The main feature of Spark streaming is in-memory cluster computing. It is faster than Hadoop, 100 times faster than Hadoop for in-memory computation and 10 times faster for on-disk computation. It supports multiple languages. Spark streaming is a scalable, fault-tolerant streaming processing system. So with the load, the number of nodes can be added, removed, so it is scalable and fault-tolerant, because any time if any node stop functioning, then other nodes will fill the gap and make sure that the processing is done without any hindrance. Spark streaming allows data engineers and data scientists to process real-time data from various sources, including Kafka, Flume, Amazon Kinesis, and so on. The processed data can be pushed out to file systems, databases, and even the live dashboards. The four major aspects of Spark streaming: the fast recovery from failures and stragglers, better load balancing and resource usage, because it's a dynamic in nature, so the load keeps changing, and with the load, the number of nodes also automatically updated so that the overall load is under balance. When any node fails, then its work is redistributed so that the load is in balance. Combining of streaming data with the static data sets and interactive queries is possible with Spark streaming. Native integration with advanced processing libraries like SQL, machine learning, graph processing is possible. So this figure explains much better. So at the core we have Apache Spark core. On top of that, the application Spark SQL, Spark streaming, machine learning libraries, and graphics apps are built on that. So they take care of separate activities, like SQL activities are taken care by Spark SQL, streaming activities are taken care by the Spark streaming, machine learning activities are taken care by MLIB, and graph related operations are taken care by graphics part of this. The Spark streaming works with the input of streaming data, and the Spark streaming converts the stream of data into batches of input data, and these batches are fed to the Spark engine, and the batches are processed, and the processed information for each batch is available one after other. So usually the Spark works on the batches, and if the data is available in live stream, then it is required to convert the stream into batches, and that is done by Spark streaming. So we can see the overview of how the Spark streaming is working. On the one side, from Kafka and all, the streaming data is available. From the other side, MySQL, MongoDB and all are providing static data, and that enters the Spark streaming world, and this are processed independently for machine learning activities. We use trained models on live stream, and the trained models with the live stream. Graphics traverse the graphs on the live stream, and data frames and data sets, part of that is used for applying functional transformations on the live stream, like mapping, reducing, and all that operations. And interactive query on the live stream with the SQL is possible through this, and all together will provide their processed information, and all the processed information is forwarded out, may go to Kafka for real-time activities, or it may be dumped onto the database, or the static portions are dumped onto the database, maybe MySQL, MongoDB, and Elasticsearch, HBase, and many such things. So that's about Spark streaming.